Moving on to areas of composite figures. And composite figures are just figures that can be divided into smaller, more basic, recognizable figures. So this area section is actually a nice sort of stopping point and a review where you'll be using a bunch of different formulas that we've derived so far. So this is a composite figure. This is actually a, looks like a triangle. It's actually a quadrilateral because these 3 points are not collinear. And to get the area of that quadrilateral, we could split it into 2 right triangles and a rectangle. So that's the idea. So if you get a good shot of this figure down here, what I really want to show you is how I want you to set up your work for me when you're submitting it so I can help you find mistakes if you make any. So if we were trying to find the area of this gray figure, it's made up of a rectangle plus half of a circle, and then an equilateral triangle has been removed from the rectangle, so we'd have to subtract that. This is how I want you to show your work. I'm not going to do out that whole problem, but this is what I would want the work to look like for that. The first line is that the area of that shaded figure is exactly what I just said. It's a rectangle minus an equilateral triangle plus a semicircle. So I want you to start with the words. I mentioned this in a previous video, just reminding you. After the words, going to change each one into the appropriate formula. So that would be on this one, rectangle is base times height minus the area of that equilateral triangle. So here's where we can use 1/2 AP, 1/2 base height, Heron's formula, or my favorite for equilaterals, if we know the side length, is the 2, 3, 4 formula. Side squared root 3 over 4. And remember, that's just for equilateral triangles. And then we're going to add a semicircle, which would just be a circle's area, pi r squared, divided by 2. And then on the next line is where you're going to substitute your values. What's the base of the rectangle, the height of the rectangle, the side of the triangle, and the radius of that semicircle. And that's it. So let's look at another example in the book. Can we get a shot of that picture there? So that one is made up of a triangle, a rectangle, and then a quarter of a circle that's been subtracted. So here's how I want you to show your work. Exactly what I just said. The area is going to equal the triangle's area plus the rectangle area minus the quarter of the circle. That's going to be your first line. Your next line is the formulas. Now this triangle was not equilateral, so we can't do side squared root 3 over 4. We can't do 1/2 AP. What we could do is 1/2 base height plus the rectangle, which is base height, minus a quarter of the area of the circle. So pi r squared divided by 4. We do have to be careful. We're using the same variable twice. We can only do that if they're really the same value. And if you look at that picture, the base of the rectangle is the same length as the base of the triangle. So those b's are fine. But the height of the rectangle is not the same as the height of the triangle. So if we really want to be accurate, we should say either b sub 1 and b sub 2, or we could do b sub triangle and b sub rectangle, something to just, I'm sorry, that's h sub triangle. The bases were fine. The height of the triangle is different from the height of the rectangle. Something to distinguish that those are different variables. So I want you to start with the words, change them to the appropriate formulas, and the next line show me what values you're substituting, and then simplify and get your answer. So let's try to ourselves. Here's the first one. What I want you to do is get a really, can we get a good tight shot of that, like a zoomed in shot of that? And students, when you get a good tight shot of that, see if you can pause the screen, and can you figure out a way you could divide this up into recognizable figures? All right, so it's a little trickier than it looks like at first. For instance, when I do this in class, a lot of students say, oh, I can make a triangle by drawing across here. Yes, that does make a triangle, but how long is the base of that triangle going to be? 1, 2, 3, 4, 5, and a little bit more. That's not good enough. So we need to divide it into figures where we have the dimensions that we need. So many ways to do it, but here's one. We could use this triangle over here, which I'm going to shade in red, because we have the base is 1 and the height is 4. Down here is a right triangle, right? If I just rotate it for a second, we could say base 2, height 9, right? As long as the base and height are perpendicular to each other. So we could get the area of that triangle 1/2 of 2 times 9. And actually, if we just use this y-axis, we now have 2 trapezoids. I'm going to rotate the picture. Here's a trapezoid. These are the parallel bases, and the height would be this perpendicular distance between them. So we could use our trapezoid formula for the area of this one. And this is also a trapezoid. These are parallel segments. Those are the bases, and a height of 3. So this average of the bases times the height. And if you use those 4 figures and then get their areas and add them up, you'll get 44.5 for an answer. So that's one way to do that one, but however you split it up, you should get 44.5 units squared. Okay, last one. Let's give them a shot of that. This one's harder than probably any that I'll be giving you from the book. So if you can do this one, or if you can follow my explanation, then you're going to be home free. So give it a shot, really hit the pause button and try this one, and we'll come back and compare answers. All right, so one thing to ask yourself is, did you show the work the way I'm asking you to show your work, which is, did you start by writing out the words that we've got a semicircle plus a right triangle plus a rectangle, and we're subtracting an equilateral triangle? And if you did that, did you do the next thing I'm going to need to see, which is what formulas are you using? Semicircle is pi r squared divided by 2. Right triangle, half base height. A rectangle, base height. Now again, I'm going to distinguish the heights are the same for the right triangle and the rectangle, but the bases are different. So if I really want to be thorough, I should say this is the base of a triangle, this is the base of a rectangle. Those are different numbers. And then I'm using that 2, 3, 4 formula because it is an equilateral triangle and I do know that side length. So one of the issues on this is some of the values that we need are not given. For instance, we don't know the base of this triangle. Hopefully you realized that we do know this is 8. And most important topic of the year, Pythagorean theorem. We can do a Pythagorean theorem on this triangle, and we can figure out that the distance from here to here comes out to be 4 root 5. If you do a squared plus b squared equals c squared, you get the square root of 80, which is 4 root 5. So the base of the triangle, the base of the right triangle, comes out to be 4 root 5. That's this. Now if that's 4 root 5, that also allows me to get the radius of the semicircle. Because if we picture that entire circle, the diameter is 4 root 5, so the radius would be half of that. So I can also write that my radius is going to be 2 root 5. I know I said that quickly, but you've got that rewind button. The other thing that we don't have given to us is the base of the rectangle. But it does say all the way across is 34. And we just figured out with the Pythagorean theorem that this is 4 root 5. So that tells us the base of the rectangle is going to be that 34 minus this length, which again is 4 root 5. So we now have all the numbers we need. You can jot these down on your paper if you need to. I'm going to put my work back in the picture here. So after I've written my formulas, now it's just a matter of substituting. The radius from the picture I just showed you is 2 root 5. Notice the parentheses because I'm squaring the entire number. Base of the right triangle was 4 root 5, Pythagorean theorem, the height was given. There's the base of the rectangle. Notice I put that in parentheses because I have to multiply that entire base times the height of the rectangle, which was 8. And then there's the side squared root 3 over 4 for the equilateral triangle. Now, if you're real good with your calculator, you could type all that in and get the right answer. I don't trust myself, so I did some simplifying. 2 root 5 squared. Well, 2 squared is 4, root 5 squared is 5, 4 times 5 is 20. Half times 4 root 5 is 2 root 5, and 2 root 5 times 8 is 16 root 5. I did a distributive property, a little bit of work here, and of course 8 squared, 64. Simplifying again, 20 over 2 is 10. I also noticed I had like terms here. 16 root 5 minus 32 root 5 is negative 16 root 5 if you combine those. So this is what I put in my calculator. You could put this in, you could put that in. But I just went all the way down. I simplified as much as I could, so here it is on my calculator, if we can just get a shot of that. Just so you can make sure you're not having any calculator issues. And on the original problem, I don't know if you noticed above, it said to round off to the nearest hundredths, 2 decimal places. So that would be 239.93 meters squared. So make sure when you're doing the homework, you show me first the words, then the formulas, and then what numbers you're substituting. Have fun!